Hi everyone, good morning, and thanks for the nice presentation, Eric. It was really insightful. We're going to build a bit on top of that and going to especially talk about the deployment part of the ML models. And we'll talk about real-time deployment of ML models, what that means and which different technologies we're having. And we'll do a real-time sentiment analysis here. So I'm going to need your contribution to make this talk happen today. Okay, I think this doesn't work now. So a couple of words about myself first. Hi, I'm Clara. I'm working as a streaming advocate at Quix. A couple of words about Quix later. Previously, I was data architect, so that's my background. I worked at Project A venture capital investor, and spent my time with advising startups and scale-ups on how to build their data infrastructure to contribute to their business strategy, to build the foundations for BI and ML. But that's now enough about me. One thing first, please already prepare the QR code reader in your phone or grab your phone so a bit quicker later. And now a couple of sentences about Quix to give you a bit context. So these are the 4 founders of Quix. They met a couple of years ago at McLaren Racing, and I don't know if you are aware of that, but I wasn't, that racing sport is so much about data collection, and they were responsible for building the system to stream the data from the cars, from the sensors in the cars into the cloud, and then make it available for the teams in the garage to make the best possible decision that in the end can decide about win or losing of a race. And a lot of companies are talking about big data, but they actually had big data. So 50,000 channels per car, meaning 50,000 metrics. We collect 50,000 sensors, 1.5 kilohertz, so 1,500 collected data points for each sensor per second. And they ran quite a lot of simulations on this data. And then realized that it took them 2 years to build up this real-time system, and thought that they want to preserve other companies from this pain of building up this system, and they found Quix, which is now a platform to develop, test, and deploy real-time data applications. So it allows you to build real-time data pipelines. We're using a streaming technology for this, so underlying under our platform, it's Kafka under the hood. And what differentiates us from other stream processing technologies like Spark, structured streaming, or Flink that you might know is that we are fully focused on Python and on data science workloads. So much about Quix. Now I want to talk a bit about real-time and streaming and how this looks like in ML. And for that, we start with a simple batch-oriented ML infrastructure. So I'm going to run through this quite quickly, as you might be familiar with that. So we're first collecting some events, some training data from our backend. We're training our model on this data somewhere in a notebook. When we have a version of a model that we're happy with, we can upload it into our model registry as the new version, and then we run the model in batches. So let's say we run it once per day. We have an offline inference platform, offline, so it's not a production system. It's not directly connected to our platform. It's running offline and producing the outputs for us. And if we now want to use it in production in our backend, then we can upload the values into an online store as a simple lookup table that then our backend can query to use our model outputs. And that's batch ML, so we're working with batch data. The features that we use are in batch. They're like 1 day old, and also the output is somehow old. So that's batch ML. So what does it now mean to go real time in ML? Well, there are 2 stages of how to go real time now. And the first one is to do the model serving in real time. And as you can see, the difference here is now that we now have, instead of an offline inference platform, online inference platform. So we are running our model online as a production system, and we're running it in real time and invoking it just when we need it. That means that we don't pre-compute all values for all our 5 million users every day again and again, but we're just computing the output for the specific user when the user is online and when we need the output, and then directly serve it into the back end. And we definitely need a feature store for this use case because we here need definitely a fast feature retrieval that just our normal data platform can't serve us with. And have now the advantage that we don't pre-compute all this 5 million values, for example, every day. Does have quite an efficient resource usage. And for example, also in case where we have high cardinality, so need an output per user item combination, there will be like billions of combinations. We couldn't really compute that in batches for every single combination that could occur, but we can do this now when we run this in real time and only compute the output that we actually need in the specific case. So that's real-time model serving. And the second step to no-go real-time is, so as you can see, we're still dealing here with batch data. So the data in the feature store is still loaded there in batches, maybe every 4 hours, maybe every day. But now if we want to work with real-time features, we need to introduce a real-time feature processing pipeline. And we're now taking the events from our backend, directly deriving the feature, storing it in our feature storage, and immediately use it then in the online inference platform to use it when we run the model. And thus have the advantage that we can use the latest data, we can use the latest events, make more, have a higher quality of our model output. And also, for example, with a user who just joined our website, our product, who we wouldn't have any data for in the previous case, we now also have data for this user and can create an output for this. So this is now real-time machine learning. So we're acting on the real-time events that are coming in and running our model here in real time. Now I want to bring this a bit into context with the different technologies we have to work with real-time data. Because we mainly differentiate between two workloads we're having that we can compute in real time. The first one is real-time analytics. Easily said, it's always when we think about a dashboard and we're having a real-time dashboard. So we're doing some aggregation over a larger amount of data, want to have the average call time our outbound customer service agents have. And and that's, if you want to have that in real time, we're mostly using real-time analytics databases. You might have heard of Materialize, Rockset, or Pinot, that then create this incremental views to provide real-time analytics. But that's not really what we're using in ML, because here we're talking about transactional workloads. So we want to act on a specific event that's coming in, and not on a huge amount of data. And for that, we basically have two different approaches. And the first one is the more traditional one. It's the model serving via an API request. So online inference platform would be an API that we're calling. And the second approach is the streaming approach, the stream processing. What's now the difference between that? So in the REST API, we're building up a request-driven architecture, which means that we have a client sending a request to a server, and the server then responding. And every time, again and again, we're opening up a connection between those two services. And these kind of communication creates some overhead for us. We have to open this communication again and again. Whereas in a streaming approach, we have two services that just create a connection once, and then it's open and events are continuously pushed. And with this, we don't have this overhead of this request and response, and can achieve higher throughput and lower latency. So especially if we talk about sensor data, IoT data that also Eric talked about. And building up an event-driven architecture, so directly reacting when an event comes in instead of having to request for it. So that's different kind of communication, but also it's quite different paradigms of architecture, where in the REST API we have a synchronous communication, so both services have to be up and running, whereas in a stream processing we are going towards asynchronous communication, so one service can send an event, and if the other service is down, not responding, or currently has to process something else still, then it's just stored in the message queue until the other service is responsive again and can consume it in their own path. And as well, when we're going towards streaming, we introduce event streams in our architecture that different consumers can just subscribe to and read from that, and we don't have to create this inter-service communication of API calls from each service to another, which can lead to quite complexity, but just subscribe to the event streams that we like, and thus have a lot of the advantages that this modern micro service architectures bring with it. So how can now an easy stream processing pipeline look like to make it a bit more graphic? So we have on one side our data producers. There can be sensors from some IoT devices. It can be event tracking we have in our platform, or it can be some change data capture from our database. And we then ingest it into our stream processing engine as a continuous flow of data. So maybe saying ingest it once is wrong, but it's a continuous event flow that we let stream through our stream processing engine, apply any transformations we want, and then output the events either into our data warehouse, into a feature store, or directly into our backend service that can react to that. And we're dealing here with unbounded data, meaning we don't really have a start or an end point. So the system also doesn't know it. It's just continuously processing events as they come in. And one maybe additional thing to mention here is that stream processing pipelines don't just allow you to transform each event and directly output it, but also within the stream processing engine, you can create aggregations and stateful processing. So if you need a feature where you want to collect, I don't know, the number of audits that were done in the last 2 hours, you can also create this kind of aggregations in the stream processing engine in memory without usage of a database. So much now about streaming and real time. Now we're jumping into the demo part and doing some sentiment analysis. And for that, we're starting with a very simple base architecture. And let's check if all of your QR readers ready and if this works now. So we're having a very simple chat app that is deployed in the Quix platform. Let me create a chat room. I'll also enter it, and now you can scan the QR code and also enter the chat room, and we can test if it works. Maybe you just write to the chat which city you're coming from. You can see if it works. Okay, we have a first message. The service is working. Yeah, cool. Nice. Very nice. But as you might have realized, there is no machine learning here yet. We're just distributing messages. So let us now introduce some machine learning. And we now want to analyze in real time the sentiment in this chat room. And for this, I'm going to leave the chat app again. We will use a pre-trained Hugging Face sentiment analysis model. So the exact model is named here if you're interested in that. But we'll not go too much into that because basically the model training happens in real-time machine learning just as it does in batch machine learning. So you're still training it on your training data set. It's still a bounded data set. And there's not too much of a difference. So we're not going to jump into details that, and we're just using a pre-trained model without any fine-tuning in this case. So let me quickly show you how this now looks like. So this is our microservice in which this model is deployed. And we are importing here the transformers library, classifying here that we want a sentiment analysis, and then we're just very easily ingesting, this is the message here that we're now ingesting into our model, and fetching the label and the score that's outputted from the model. So the model works in a way that it gives us a label if it's negative or positive message, and then a score, how confident the model is that it is positive or negative. We're grabbing the values, and then we're putting together our output message. We want to have the chat message again. We want to have the sentiment. And here you can see what I just talked about. This is a line that is for the stateful processing. So we're creating an average sentiment, a running average calculation that we can do because we're keeping a state in memory in the stream processing pipeline. So creating an average without a database involved. So let's check if this now works. Cool. So maybe to take a controversial topic and to check if we analyze the sentiment correctly, let's put our opinions on Web3 and crypto into the chat room and check the sentiment in this room about, decentralized infrastructures. I think it's the same QR code as before that you can use. And here you can see the average running sentiment that's calculated. Okay, I think with crypto rules, we have a wrong classification. That should probably be a positive one. Yeah, doesn't solve any problems and too complex. Awesome. No clue. A bit mixed, average sentiment of 0.4, so we're rather positive about crypto here.
I think I have to interrupt. I'm really, really sorry, but we have another speaker.
Yes.
Lineup. Sorry.
So
but it was
cool,
a
but
cool demo. You know,
but it worked.
I never would stop anybody from demo. Like, demo is the most important part of everything. So
cool. We have it running now anyways, and as you can see, it's computing the sentiment score in real time. So latency is about 10 milliseconds. We're in a very low latency here. And yes, thank you very much for contributing to this demo. I don't know if you have time for questions.
it's difficult now. I think we're really passed over.
We'll be around, so you can approach my colleague Theo or me if you have any questions, or try out our product for free if you like. And thank you very much.
Thank you.